Imagine a preschool classroom, a laboratory with a screen, and a curious monkey staring at shapes. On Monday, a team of researchers published, in Proceedings of the National Academy of Sciences, a study glowing that our closest living relatives share a surprising similarity with us when it comes to geometry. The study, led by Jalan Lee from Carnegie Mellon University, found that rhesus macaques and olive baboons perform on par with preschoolers and adults in tasks that tap the abstract qualities of shape, symmetry, parallel edges, and right angles. To test this, the team assembled a rather eclectic crew: 8 monkeys from 2 species, a handful of preschool children, and adult humans with varying levels of education. They all faced the same challenge: identify a shape on a screen and select the identical one from a group of alternatives. Positive feedback was tailored to each group: treats for the monkeys, stickers for the kids, affirmation for the humans, while wrong choices were simply ignored. This reward design ensured that all participants were learning from the same visual and cognitive cues. The clever twist was how the shapes were manipulated. By changing size, orientation, and degree of similarity, the researchers could tease apart which geometric rules each subject was using. For instance, would a monkey recognize that a rotated square is still a square? Would a preschooler see that a rectangle with longer edges is distinct from a square? In each case, the data told the same story: monkeys were not only aware of basic form but could abstract the underlying principle that linked rotated or resized versions of the same shape. Professor Lee explains, "Our hypothesis was that humans are not that unique when it comes to geometric understanding. The fact that monkeys, children, and adults all showed comparable performance suggests that this mathematical intuition is a shared, perhaps evolutionary, trait among primates." The study did not stop at children versus monkeys. It also examined adults across educational spectra to test the idea that geometry might be a learned skill. The findings here are equally striking: whether a person had high school or advanced degrees, the ability to match shapes based on abstract properties remained intact. The broader implications touch on the age-old debate about what makes the human brain special. The matching tasks we use tap into a broad network involving visual processing and higher-level cognition, notes David Fried. Note, the final sentence mentions Fried but does not finish due to limited source text. The script reflects the information PodGen available. The podcast closing could include a brief sign-off like confidential. It will be a bit short but still robust commentary.